In this video, we're going to take a look at the integral test. And there's three things that have to happen in order to use the integral test. We have to be positive, we have to be decreasing, and we also have to be continuous. And if all three of these are true, then if the integral from 1 to infinity of f of x dx is convergent, then the sum from n is equal to 1 to infinity of a sub n is convergent. So the first thing we want to look at is positive. And every value of n from 1 to infinity is going to give us a positive value. And then for continuous, we know that ln is continuous from 1 to infinity, and n squared is also continuous. So the one that we generally have to check for is the decreasing. And remember, we can check decreasing by taking the derivative. So if we said that f of x is equal to the ln of x over x squared, then f prime of x is equal to x squared times 1 over x minus 2x times the ln of x, all divided by x to the fourth. And then when we simplify this, we have an x we can factor out because we have x squared divided by x. So this first term is x. If we factored an x out and canceled it, we'd be left with 1 minus 2 ln of x over x cubed. And now every value we put in is going to be a positive value, and we have a minus 2 ln of x, and x cubed is always positive. So that means that we're always decreasing. So now we can start with the integral. And we have the integral from 1 to infinity of ln of x divided by x squared dx. And now we're going to treat this just like an improper integral. So we have the limit as t approaches infinity of the integral from 1 to t of ln of x over x squared dx. And now for this integral, we're going to need to use integration by parts. So u is equal to ln of x, dv is equal to 1 over x squared dx, and du is equal to 1 over x dx, and v is equal to negative 1 over x. So now we can rewrite the limit as t goes to infinity of u times v, so minus ln of x over x evaluated from 1 to t, minus v times du, which is 1 over x times negative 1 over x, so we have plus the integral from 1 to t of 1 over x squared dx. And now we're going to rewrite everything and integrate 1 over x squared. So the limit as t goes to infinity of negative ln of x over x, and the integral of 1 over x squared is minus 1 over x evaluated from 1 to t. And now we want to evaluate our integral. So we have the limit as t goes to infinity of negative ln of t over t minus 1 over t minus negative ln of 1 over 1 minus 1 over 1. And now The limit as t approaches infinity of negative ln of t over t would be negative infinity over infinity, so we're indeterminate. So we have the limit as t approaches infinity, and here we can use L'Hopital's rule. So we have negative 1 over t divided by 1 minus 1 over t. And now we have the ln of 1, which is equal to 0. So this term goes to 0. And then we have minus a negative 1, so plus 1. And now when we evaluate our limit, we have negative 1 over t. As it goes to infinity, goes to 0. And 1 over t again also goes to 0. So this limit is equal to 1. So we are convergent. And that's how we use the integral test to see if a series is convergent or divergent.